Question 23. Simplify the following exponential expressions. So for this question, we're going to use some of the properties of exponents, and we must also keep in mind the order of operations, that the parentheses comes first, exponent comes second, then the rest, okay? So for part A, I'm going to focus on the parentheses first. I have negative 3 times 5 cubed is 125, and then 3 cubed is 27. So that is equal to negative 3 times 98, which is equal to negative 294. Okay. Part B, again, so here I see that I have a negative a here squared. I have to first take note that negative a squared is positive a squared. Okay, and then I have negative 3a cubed times 2a times a squared. Alright, so I can go ahead and multiply the two numbers. I get a negative 6. Now, I see that I have a cubed, a to the 1, there's an invisible power 1 here, and then a squared. Since all three of these have the same base, a, I can just go ahead and add the exponents. So I have a to the power 3 plus 1 plus 2, and I get negative 6a, and that's 6. Okay. Alright, part C. Alright, so I'm going to apply the property of exponents in here again. I see that I have the same base, z. I'm just going to add these two exponents. So I'll have z, negative 2 plus 5 is 3. And then I'm going to raise that to power 4. And then we're going to use another property of exponent that says, in this case, we can just go ahead and multiply the exponents. So I get z, 3 times 4 is 12. Alright. Okay, so for part D, I see that I have 2 times y to the negative 5. So if you want, here the power of y is negative 5, but if you want that power to be positive, you can go ahead and reciprocate that term. So we keep the 2 there, and I'm going to reciprocate that term, and then the power is going to become positive, so y to the 5. But if we multiply across, I get 2 over y to 5. Right? For the next one, notice in part G we have the same base and they're all multiplied together, and there's an invisible power 1 here. In this case, I can just go ahead and add up all of the exponents. Okay, x2, 1 plus 2 plus 3 plus 4 plus 5, and that is equal to 15. Alright. Okay, the next one, again, the same property that we used in part D. I am going to reciprocate this term here. I'll get 1 over 6 squared. Now the exponent became positive, and this is equal to 1 over 36. Okay, part I. So here's a property of exponent that says anything to power 0 is always equal to 1. So here the answer is 1. Okay. Part J. Okay, so here I would go ahead and focus on this term first, and then we'll move on to this next term. So 3y squared, it gives me 9y squared times, now another property says that we can multiply the powers. We get y, 3 times 2 is 6, and then keep the 9 there. Now another property says the same, the bases are same, so just go ahead and add up the powers. So we get 9y to the 8, because 2 plus 6 is 8. Okay? Alright, part K. Alright, so for this part, we're going to focus inside the parentheses first. We want to go ahead and simplify inside the parentheses as much as we can before we cube everything. Alright, so let's see here. I see that inside the parentheses, the 3 stays there, but notice 1a from the denominator cancels one of the a's from the numerator. So we have 1a there. And also notice that one of the b's from the numerator cancels away one of the b's from the denominator. But there's still one b left, right? So inside the parentheses, we have a simplified expression of 3a over b. Now then we can go ahead and cube it. Okay, so we have 3a cubed over b cubed, and this becomes 3 cubed is 27, a cubed over b cubed, and that is our final simplified expression. Okay, and then one last one. Okay, the same concept applies here. Let's go ahead and simplify the numerator first. Same basis. We've got z, 2 plus 4 is 6 over z cubed, and then raise that to power 5. Now, another property of exponents says when you have the same bases and you're dividing the two terms, you can just go ahead and subtract the powers. So I get z to the power 6 divided by z to power 3. 6 minus 3 is 3. And then I'm going to raise that to power 5. And then now I can just go ahead and multiply the powers. I get z to 15.